Okay, so when we have pulleys, you always need to take the particles separately because they're going in different directions. We've got particle A, which has got a mass of 5m, so its weight will be 5 mg. So everything is in terms of m, so we don't need to worry about that. And B is kmg. Now we're told that k is less than 5, so we should be able to see that k is going to go upwards and B is going to go, and 5m is going to go downwards. We're told the acceleration is a quarter g, and we know that it's released from rest. Because there's a string, obviously there's a pulley and it's a string and it's the same string, we can put our tensions in on the system, and it's the same tension throughout, because part C actually is you're using that fact that the pulley is smooth because there's no friction, so it's the same tension all the way through. And what we're going to do to answer these questions is take each particle separately. So for part A, I'm looking for the tension in the string as A descends. So I effectively snapshot what's going on for particle A, and I do Newton's second law. I'm resolving downwards because it's moving downwards. So resultant force is equal to MA. My resultant force is going to be 5 mg minus T, and that's going to equal 5m multiplied by my acceleration, which is a quarter g. Now rearranging for T, I'll have 5 mg minus 5 mg over 4, so T is equal to 15 mg over 4 as required. For part B, I'm looking for the value of K, so I'm now going to look at what's happening for particle B using Newton's second law again, but this time obviously it's going upwards. So my resultant force upwards. So resultant force is equal to mass times acceleration. So it will be T minus kmg is equal to km multiplied by a quarter g. I know that T is 15 mg over 4 minus kmg is equal to kmg over 4. Now my mg's all cancel out. So I would have 15 over 4, and taking this k over here to add to the quarter, I would have 5 over 4 k, so therefore I know that k is equal to 3. So that's part B. For part C, show how you've used the information that this pulley is smooth. Smooth pulley, no friction, so therefore we're assuming that the tension is the same throughout. Part D is where it gets a little bit more tricky, and these are always the bits in the question where you need to be a bit more careful and think about what's going on. So A moves down for 1.2 seconds. Obviously B moves up for 1.2 seconds. But then when this hits the ground, this hits with a velocity. Started with no velocity from rest, obviously, and it moved down with a quarter g. So this moved up with a quarter g, started with no velocity, has got here, and it has actually got a velocity. So this VB has got a value, it doesn't just stop in midair. What happens then is that this then moves up further. If I move this down to here, and then stops. So this is VB at this point and then stops here. So the question is actually looking for the greatest height reached by B above the plane. So if we think about above the plane, if I do another diagram over here to show a bit smaller, we've got this moves down to here, this moves up to here, so these distances are the same. but then obviously this goes a further shorter distance here. So the total distance above the plane will be from here to here, which means that this part is the same as this bit. So we would have a D1, D1 and D2. So that's the overall final answer that we're looking for. So if you look at these bits individually, if I look at this portion and I use Suvat, my S is my D, what I've called my D1, which is that's D1 obviously, and that's D1, which is the same. So as one moves down, the other one moves up. So D1. U, 0. V, I've called it VB. A was a quarter G, and I know that T was 1.2 seconds. So from this, I can find D1 and VB. So if I find D1 first of all, so I'm going to use the one that I don't need V in, so it's going to be S equals UT. S equals UT plus a half AT squared. So D1 is equal to a half multiplied by quarter G times by 1.2 squared. So D1 from my calculator comes out as 1.764 metres. Using this Suvat as well, I'm going to find VB. So this time I'm going to use V equals U plus AT. So VB is going to equal a quarter G times by 1.2, which is equal to 0.3 G. So this VB now transfers into this part where it's then moving from this velocity and then stopping. So my Suvat for this portion would be, I'm calling that one D2, if you remember that was D2. U is my VB, which is 0.3 G. V is 0 because it's stopping, and A was minus G, which is 9.8 obviously. So I want the one without T in it, so I'm going to use V squared is equal to U squared plus 2AS. So 0 is equal to 0.3 G all squared plus 2 times by 9 minus 9.8, and that was my D2. So D2 is equal to 0.441 metres. So therefore, oops, I don't know if you could solve that then. So therefore, the total height that's achieved by particle B will be 2 lots of D1 plus my 0.441 metres. I don't need that, put that in at the end. So times by 2 plus 0.441, which is equal to 3.97 metres, and that's to 3 significant figures.